Okay guys, so let's take a look at this question. So we have an object that's suspended from a string AB that's pulled to the right horizontally by a force of F as shown. So given that the force F is 4 Newton, so we know that this force F here is 4 Newton and the weight of the object is 3 Newton, so there should be a downward force going down to be 3 Newton. We are supposed to draw a labeled diagram to determine the tension of this string, which this tension of the string is likely going to be going upwards, so we're going to label this as T. Now, there's two ways in which you can solve this method, so I'm going to do the first one, which is what we call the parallelogram method. So for parallelogram method is to resolve forces, or rather resolve vector diagram in two forces. So I have three here. How do I use parallelogram method to solve the question if I have three forces? So we have to assume that one of these forces that we are trying to solve will be the resultant force, which means that we will only consider this 3 Newtons force as well as the 4 Newtons force, and we will let this tension be the resultant of this and this. Okay, so how do we actually go ahead and solve this question? Let's use the blank space that is at the other side of the page to solve this question. So first we need to decide this space. So roughly we should try and fill up this space as much as possible. So I know that this is 3 and this is 4. So looking at this space, I think a good scale would be to use 1 cm to represent 0.5 newtons. So I will go ahead and write the scale here, and I will use 1 cm to represent 0.5 Newton. So with that, then let's just go ahead and draw our forces. So I have my weight to be 3 Newton, that means I have a 6 cm. So I'll just draw a 6 cm down using a ruler, so it should be as precise as possible. Now I'm drawing in pen because I'm quite confident on what is the diagram that I want to draw. So if you should be using a pencil to draw in case there are some of the corrections that you need to do, or unless you draw it wrongly, you can erase it easily. So this, I'm going to let this be my weight. So I'm going to draw an arrow and label this as 3 Newtons. Now I know that there's a horizontal force to the right, and this is 4 Newton. So if I use the scale and convert accordingly, I should get 8 cm. But before that, we know from this diagram, okay, that the angle between 3 newtons and 4 newtons is 90 degrees because F is horizontal and weight is vertical. So this is 90 degrees. So we have to use our protractor. So if you take a protractor, okay, and then you try and measure this to be 90 degrees. Okay, so I'm just going to put a marking here. So after I measure this to be 90 degrees, I can go ahead and draw this force, which is 4 newtons, which according to the scale is going to give me 8 cm. So once I have the 8 cm here, again I can go ahead and label this as 4 Newton. Now, so this is the parallelogram method, and so I want to complete the parallelogram. There's two ways you can do it. One is by scaling. So when I say scaling, you will need another ruler. So let's say you take another ruler, okay, and then you place this along this side of it, and you place the other ruler here. You can sort of push this ruler down towards the other end and you draw your parallelogram. But I don't like to use this method because sometimes my ruler can go off and becomes inaccurate. So I usually will prefer just to measure this again. So since I know that this is 90 degrees, that means the one at the bottom should also be 90 degrees. So I'll measure this to be 90 degrees. And now I will put a dotted line across, and this dotted line should be the same length as the 4 Newton above, so that should give me 8 cm. And then now I will complete this parallelogram. Let me just double check. So I slightly exceeded 8 cm, so I'm just going to start from here instead, and then we'll complete this parallelogram here. So now I have completed my parallelogram. I'm almost done. So the last step to this parallelogram method is to draw from, you see these two forces, we will draw for the middle, okay, the middle of these two forces, not here, not the middle of this solid line and the dotted line, but the middle of these two forces towards the other end. And this should be a solid line because we are drawing the resultant force. And we will label this with a double arrow because it's a resultant force. So how do we label this? We will use our ruler to measure this, and it gives us actually 10 cm. So 10 cm, if I convert back the scale, so 10 cm, 1 cm is 0.5 Newton, so 10 cm is actually 5 Newton. So that is our resultant force. So this 5 Newton is the resultant force of 3 Newton and 4 Newton. So this, however, is not actually the tension. This is the resultant force of this and this. But we know that this 5 Newtons, according to this diagram, should balance the tension. So we can say that, we can write a note here that we say that the resultant force is equal in magnitude and opposite in direction of the tension. So this is a note so that we know that this resultant force we are finding actually will end up to be equal in magnitude and opposite in direction to the tension, and we can write our final solution here as 5 Newton. That's how we will use parallelogram method to complete this particular question.